What do you mean by centripetal acceleration? In your data booklet, it is simply denoted with A, but I will denote as AC to specify the centripetal acceleration. What we are discussing is the uniform circular motion, right? So whenever we are discussing uniform circular motion, the object is moving in a uniform circle with a constant velocity. And that we discussed that the velocity is, let us say the object is at this point. The velocity is always tangential to that particular point. So tangential means which touches the circle exactly at one point. So this is my velocity. Now we are saying uniform circular motion, it means the magnitude is not changing, but the direction is changing. So can I say velocity is changing due to change in direction? And we know that change in velocity leads to acceleration. That is how we define the acceleration. Acceleration is the rate of change of velocity. So as the velocity is changing because the direction is changing at every instant of time, let us say if you are at this position, the velocity will be tangential to the point. At this point, it will be tangential. So at every point, the velocity is tangential to the given point in a circular motion. And therefore, the direction is changing. And direction changes, velocity change leads to acceleration. And this acceleration is known as nothing but centripetal acceleration. There is a very common misconception among the student that acceleration always means that speeding up. It's not necessary. Acceleration can also be act in a system if there is a continuous change in the direction. And this acceleration is always acting towards the center of the circular motion. So it will always be pointing towards the center. So I will call this as AC. So always your centripetal acceleration and your velocity will make an angle of 90 degree. The direction of velocity and the acceleration will always make an angle of 90 degree. Or in other words, you can say if velocity and acceleration are perpendicular, this symbol means perpendicular, are perpendicular, then the motion of an object, then the motion of an object will be circular motion. If it is uniform or not, that is a different point, but definitely this will be circular motion. And the acceleration acting towards the center is the centripetal acceleration, whose equation is given to you if you check your data booklet, go to A.2. If you see the second last formula in your data booklet, I will write down as it is V square over R, where R is the radius, equals to omega square R. I'm writing capital R so that you do not get confused with my pi and R because I write down the same way. 2 pi R, 2 pi square R over T square. These all are different expression for your centripetal acceleration. So we'll discuss how we will get each of them. So A is equals to V square by R, right? For to get to know how we got this equation is not the part of our syllabus, so I'm not discussing it here. But even if you want to know, this is simply using the similar triangle property. So you will equate and you will get this equation, but I'm not getting into that part, especially for SL student, it is not required, and even for HL also, we will directly use this formula. But we can get these equation using the previous relation. So we know that V is equals to what? Omega R. We discussed this in the last class. So V I will replace with omega R. So it will be omega square R square over R. One R and one R gets cancelled. So we get A equals to omega square R, where omega is angular velocity. Similarly, we also know that from here we can say omega is 2 pi by t. This also we discussed in the last class. So I replace this 2 pi by t whole square times r. So this will become what? This will become, uh, this is 4 pi square, my bad, not 2. This is 4 pi square. So this will become 4 pi square r over t square. So no need to worry, you can directly use these equation because it is given in your data booklet. DB stands for data booklet. Now many students get confused, so we don't know the centripetal force. So we know that by Newton's second law, what is Newton's second law? What is the equation for Newton's second law? F time equals to mass times acceleration. Now we are finding out the centripetal acceleration. So centripetal acceleration will be what? Mass of the object times centripetal acceleration. So centripetal force will be the net force acting towards the center. This is the net force, as we already discussed. Net force acting towards center. So that will be your center, because we are discussing Newton's second law. Newton's second law says the net force acting on an object is equals to mass times its acceleration. So if we are applying this in the form of a circular motion, then the net centripetal force is nothing but the net force acting towards the center will be your centripetal force. Now this, I just multiply m because this is given in your data booklet. So if you multiply m to each of this equation, you will get the formula for centripetal force. So centripetal force is m v square over r, m omega square r, 4 pi square r over t squared times m, like this. So this will be nothing but your centripetal force. Also make a note point here. The centripetal force is not a type of force. It is a category, or you can say it is a net force acting towards the center when an object moves in a circular motion. That's it. So it's not a type of force like friction, normal contact force, um, applied force, buoyant force. These all are different types of forces that we discussed in 8.2. But here, centripetal force is just the net force. We never draw the net force on a free body diagram, right? So make another note point here that centripetal forces are not drawn on in a free body diagram. I mean, any free body diagram. Centripetal force like FC. You will not show FC acting towards the center. No, that's the incorrect way of drawing the free body diagram. When we are drawing FBD, we only draw the forces acting on the object, not the net force acting. Have we ever draw the net force in 8.2 in a free body diagram? No. So the same thing applies here as well. So the centripetal force is not drawn in a free body diagram as it is not a type of force. It is simply a net force acting towards center, which changes the, which is responsible, you can say, which is responsible for the change in for the change in direction of an object moving in circular motion. Because we know that we are discussing the uniform circular motion, so there is no change in the speed. So this force is actually changing the direction. Because according to Newton's first law, we know that we need to apply an unbalanced force in order to change the state of motion. When we say the state of change of motion, which includes the direction as well. So without the application of force, you cannot change the direction of any object. So in other words, you can also say that this force is also acting towards the center. So the direction of acceleration and the direction of the centripetal force is the same. Force and velocity will also make an angle of 90-degree whenever the objects are moving. Now there are different cases uh, can be possible for an object moving in a circular motion. So let us take examples. So we take one example like different types of centripetal force, or you can say um, identifying identifying these centripetal force in different situations. So let us say if I say the first, like I'm just discussing the common questions. You need to know the things when you apply it in your questions, but generally the questions are related to this part only. So for example, this is our planet Earth, and we know that the moon is revolving around the Earth, right? In a fixed circular orbit. Let us say this is our moon. So what is the force acting between the Earth and the moon? Why the moon is
Gravitation.
revolving in a circular motion? Very good. So we know that the moon is revolving around the Earth because of the gravitational force. So when I draw the free body diagram for this case, I will simply draw a force acting towards the center of the Earth, and I will name it as Fg, not Fc. But Fg, or you can say the force of gravity, is my centripetal force. We will learn about the gravitational force between the Earth and the Moon, but just to write it down, mass of the planet Earth, mass of the Moon divided by r square. R square is the distance between the Earth and the Moon from their center. This will learn in unit D.1, so don't worry about it. So I'm just saying that will be equals to your centripetal force, or the mass of the planet times mass of the moon divided by r square is equals to m. That is, who is moving in the circular motion? The moon. So this is the mass of the moon into its velocity square divided by r. So this is how we will equate. I think you might have learned this Newton's law of gravitation in your lower grades. But as of now, you just know that the force of gravity is equals to the centripetal force. Another case is like, sorry, this is most of the time student get confused here. The friction when also provides a centripetal force for a vehicle which is moving in a curved path on a horizontal surface, like you are taking a turn on in a circular or roundabout. So in that case, there is a frictional force which is acting towards the center. So let us say this is a circular track and your vehicle is, let me get the vehicle here. Let us say like this. The vehicle is turning. This vehicle is moving like this. So this is the, let us say, the center. So the vehicle friction will be provided here by the tires. So the friction is equals to your centripetal force in such situation. When a vehicle turns on a curved path. And what is the formula for friction? We already discussed this in 8.2. Yeah, nu times Fn is equals to mv square over r, where m is the mass of the car. Always remember, whenever you're putting a formula of centripetal force, this m is the mass of the object moving in the circular motion. So here it is the car, so this will be the mass of the car. Fn here you can simply say mg is equals to the weight is acting downward, normal force. So nu times mg is equals to mv square over r. So for a safe ride, like if you want to take a safe turn, your vehicle do not get to skid. So your velocity should be less than or equals to friction, because if it is greater than, friction has a limiting condition. We already discussed this. So friction cannot go beyond a certain limit. So we need to make sure the velocity is under the safe limit. Otherwise, your vehicle gets skid and you may uh, get into an accident, or your vehicle get flipped. So I will for safe turn, we must be, or you can say the centripetal force must be less than friction. So if I apply this, I can say nu mg is greater than or maybe equals to mv square by r. So this and this m gets cancelled. So we get a safe velocity should be either less than or equals to nu g r and then a square root. This is a very important concept. Please make a note of this thing, guys. I have seen many questions directly asking from this. And if I now ask you a very important question, like why, you might have noticed that there are banked track. The tracks are slightly inclined when you are taking a turn. The road is not completely horizontal. It is slightly inclined inwards. Like if you're taking a turn, it will be like this. And if you're taking a turn like this, it will be like this. Why they are
Oh, yeah.
at a certain angle? Yes, the speed can be greater. Okay, if a greater speed is desired for the movement around a curved track, friction may not be enough, and that is why we bank the track for greater speed, so that a component of the contact force can act in the necessary direction. So if it is a banked road at a certain angle, then the component of your contact force will be like Fn is perpendicular, so a component of Fn will be towards the center. So there will be one more force added it here. Not here, sorry. One more force will be added it here, like mg cos or sine, whatever. So you can have more speed then. So if a greater speed is desired for the movement around a curved track, friction may not be enough. So by having a banked track, greater speeds are possible, and it is safer because a component of the contact force can act in the necessary direction. If I ask you a very interesting one, this thing. Okay. So watch this video carefully and then I will ask you one question. Look at the surface. And look at the base of the floor. Now the floor drops out. Okay? And they are still sticking to the wall. My question is, if I take a screenshot here, my question to you is very simple. Draw the free body diagram of any one person of your choice. at this stage. Draw a free body diagram. Draw a free body diagram of any one person from the image. Why they are sticking to the wall, not falling down. So draw the free body diagram. Okay, pay attention now. So these persons are not falling. Let us say I take this small person, I will draw a dot to show the person here. So look, weight is always vertically downward, that is for sure, which you can say W or mg. Now they are not falling because this person has a tendency, because of the weight, it needs to move down. But this surface of the gravitron, right, the wall, has a friction. So the friction is holding them in the upward direction. So in this case, your friction is acting upward, the weight is acting downward, and they are in contact with the surface. And I told you, whenever they are in contact with surface, a normal force will be acting perpendicular to the surface. So this is the free body diagram where these two forces are equal, and the centripetal force is your normal force here. And that is the reason why you might have seen in the video that they need a certain speed, then only they can have they can remove the flow, otherwise the person will fall. Why? Because once they have the a particular speed, the friction is equals to what? The friction is equals to your centripetal force, which is mv square by r. And we need a particular, sorry, not friction, the normal force is your, the Fn is your centripetal force. So whatever the force is acting towards the center, we equate that with the centripetal force. So normal force is your mv square by r, right? So we need more normal force to increase the friction. So because friction is what? Friction is nu times Fn. Friction is nu times Fn. So friction will only increase if normal force increases, and normal force depends on the speed because m is constant, r is constant. Mass of the person is not changing, this radius is not changing. So we need to rotate this ride very fast so that the normal force increases. Normal force increases the friction, which counterbalances the weight because weight is constant. Okay. Another type of questions may be related to like a string, like simple string is attached and you are rotating. Stone is attached to a string and you are rotating. So, like for example, I'm rotating this object in a circular motion like this. This is my radius r from the center at an angle theta, let us say. So can you draw the free body diagram of this object? Let us say the object has a mass m. I asked you simply draw the free body diagram of stone mass m tied to a string moving in a horizontal uniform circular motion. The angle with the vertical is theta, the radius is r. So there are only two forces acting. One is the weight, which is vertically downward, and there is a tension T acting. As I told you, tension is always away from the object. Only these two forces. Now, what I asked you is what could be the centripetal force? Now, that is what we need to think here. So you can see, let us say, can I say that this angle is theta? So this angle will also be theta, interior opposite angle, parallel line. So this is theta. Okay, if this is T, this is theta, what would be this component? I want to resolve this tension. So this will be T cos theta, and here it will be T sine theta, and here it will be weight. Now, if it is moving in a horizontal, So T cos theta will be equals to your weight, which is mg, let us say. This is my equation 1. And T sine theta is the force acting towards the center, which is equals to mv square by r. So these things you need to now connect. Any force, the overall conclusion of this whole different cases which I have shared, the noted point is the net force acting towards the center, that you need to figure out, and that you have to equate with mv square by r. Simple. That will be equals to mv square by r. Whatever is the net force acting, just equate that towards the centripetal force, that is mv square by r. So if you understood this thing, when you read out the question, you have to think what are the forces acting, resolve it. If it is not directly given, try to figure out the net force acting and then equate that with the mv square by r. 80-90% question is solved. And then you just have to play with your equations. That's it. Now, there is a little bit in our syllabus about the vertical circular motion. So it is very easy now if you have understood this much. So vertical circular motion. This is a type of non-uniform circular motion. I will let you know why. Till now, we discussed whatever we have discussed is all uniform circular motion. Now, this is a vertical circular motion. What do you mean by vertical circular motion? In a vertical plane, the object is moving. Like, let us say if this is my object here, and I'm moving like this. So it is moving like this. It is a vertical
Yes.
motion, right? So the examiner will ask you at the bottommost point and the topmost point only. So let us say if an object, the same object is moving in, this is my center, and this is my circular motion, let us say. Let us keep this as center here. Okay. And this object, there is a ball. Let me add a ball here. Let us say this ball is tied to a string. This ball is tied to a string. This is the one position at the bottommost, and this is the, let me take this object at the top position. Can you draw the free body diagram of these two positions? The top and the bottommost, that's it. A ball of mass m is attached to a string and moving in a vertical circular motion at the bottommost point and at the topmost point. Okay, so at the bottommost point, if I need to draw, so I can simply say that weight is acting downward and tension is acting upward, but tension will be greater here because it is moving in a uniform circular motion. And for the topmost point, I can simply say weight is acting downward as well as tension is acting downward. So as I mentioned in the previous part, that the net force acting towards the center will be my centripetal force. Say this is what I draw earlier. Yeah. So we know that the net force acting towards the center is what? The centripetal force. So I can simply say here T minus W is my mv square by r. This is my equation here. So tension here it will be mv square by r plus W. So the tension will be greater when the object is at the lowest point. This is W, don't get confused. This is not omega. This is, or I can say mg. This is mg. weight mg. And here it will be what? Here it will be W, or you can say mg plus T is equals to mv square by R. So T will be mv square by R minus mg. So tension will be less here. Now I pretty much covered everything from the circular motion